Welcome to Future Forward, where we explore groundbreaking technologies. Today, we're diving into Passive Daytime Radiative Cooling, or PDRC. Imagine cooling buildings or even yourself without using any electricity. That's the promise of PDRC. It's a fascinating technology that works by reflecting sunlight away and simultaneously radiating heat out into the cold of space, even when the sun is shining brightly. So, how does it actually work? PDRC materials are super smart. They're engineered to be highly reflective to sunlight, which means they absorb very little heat. At the same time, they're excellent at emitting heat in a specific infrared range where Earth's atmosphere is transparent. This allows the material to send its heat directly to the extremely cold outer space. We're talking about -270 degrees Celsius. This 1-2 punch of reflecting sunlight and radiating heat allows PDRC surfaces to get cooler than the air around them, even in direct daylight. Scientists are making huge strides in developing PDRC materials. Think special coatings and paints that can be rolled onto rooftops, reflecting over 95% of sunlight and radiating heat just as efficiently. Some new paints are even water-based and eco-friendly. Then there are advanced films and thin layers, some just nanometers thick, precisely designed for cooling. We're also seeing PDRC integrated into fabrics for cooling clothes, hats, and gear, perfect for staying comfortable outdoors. Researchers are even looking at ceramics and composites, inspired by nature, that are incredibly reflective and durable for buildings and roads. Lightweight aerogels and even specially treated wood are also being explored. There's even research into smart PDRC materials that can switch their cooling abilities off when it gets cold. What makes a good PDRC material? Key things are super high sunlight reflection, ideally over 90%, and equally high heat emission in that special infrared window. The cooling power is also important, often measured in watts per square meter. Good materials can remove around 100 to 150 watts per square meter. And critically, they need to achieve a noticeable temperature drop below the surrounding air, sometimes 5 to 10 degrees Celsius or more. The applications are vast. Primarily, PDRC can cool buildings, slashing air conditioning costs and energy use. Personal cooling clothing is another big one. Think about cars staying cooler, electronics running more efficiently, or even keeping water and food fresh without power. PDRC materials on roads and urban surfaces could also help reduce the urban heat island effect, making our cities cooler. Some designs can even help harvest water from the air in dry regions. Of course, there are challenges. Making some advanced materials affordable and at a large scale is one. Durability against weather and pollution is crucial. Performance can also vary with climate. High humidity can sometimes reduce effectiveness. And while white is often best for performance, more color options are needed for wider use. Developing truly dynamic and cost-effective switchable materials is another ongoing quest. Despite these hurdles, the future of PDRC looks bright. Continued advancements promise a significant passive cooling solution. It's a technology that can help us save energy, cut greenhouse gas emissions, and simply make us more comfortable in our warming world. That's PDRC, cooling the planet, one surface at a time. Thanks for tuning into Future Forward.